Ooh, that quick flash. Did you see it? That's an object smashing into the moon at unbelievable speed. And what makes it so special is that we almost never catch lunar impacts in real time. We still don't know what exactly hit it, but scientists think it might be linked to the Phaethon asteroid, one of the strangest, most mysterious objects we know of. This impact happened on December 12, 2025. Andrew Marshall Lee, a final-year PhD student, was doing a late shift at the Armagh Observatory and Planetarium in Northern Ireland. He was working with the Armagh Robotic Telescope, the newest and most advanced one there. Everything seemed normal at first. The moon was just sitting quietly on his screen. But then, around 3 in the morning, something unexpected happened. He saw a flash. That was the impact of a small object hitting the moon. The team is still trying to pin down its exact size, but they think it was no bigger than 2 inches across, which is about the size of a golf ball. And this object was moving insanely fast, at about 22 miles per second. To give you an idea, it's more than 100 times faster than a commercial jet. And yeah, I get it. When you watch the video, it's only a quick blink. It's not exactly thrilling. But the fact that Marshall Lee caught the exact moment it happened is actually super rare, and that's what makes this one such a big deal. It's the first video recording of a lunar impact flash in Ireland, and only the second one ever recorded from the United Kingdom. But just because it's rare to see that kind of event happen, that doesn't mean impacts on the moon are rare. It's actually the total opposite. We have a huge advantage on Earth, our atmosphere. It works like an invisible shield. It slows down incoming space debris, and it can even burn a lot of it up before it reaches the ground. But the moon doesn't have that kind of protection. So our poor natural satellite gets hit all the time by asteroids and meteorites. The good news is, most of what hits it is tiny, no bigger than little specks of dust. Now, if we talk about slightly bigger ones, we can look at some rough numbers. Scientists think around 100 space rocks the size of ping-pong balls hit the moon every single day. That adds up to roughly 36,000 in a year. So, it's kind of strange that we don't capture these impacts more often. But the explanation is actually pretty simple. As we mentioned earlier, these space rocks are usually tiny, and if a ping-pong ball already looks small here on Earth, imagine something that size flying through the huge emptiness of space. We can say it's basically invisible. That's why we usually can't spot them with a telescope. They're too faint for that. But the moment one of these little objects hits the moon at a crazy high speed, everything changes. The energy from the impact turns into heat and light. It blasts and melts a bit of the surface, and for a split second, it makes a bright flash that we can see from Earth. And there's one more problem. The moon is huge. Impacts can happen anywhere on its surface, so it's almost impossible to keep a telescope pointed at the exact spot where the next big hit will happen. So, most of the time, scientists don't catch lunar impacts with their own eyes. What usually happens is that they record the moon for hours, run all that footage through some software, and the program flags it if a flash shows up. But in Marshall Lee's case, he just happened to be looking at the screen at exactly the right moment, and he saw it happen live. Now you get how lucky he was, right? For now, the team has a pretty good idea of this space rock's size and speed, but it's still hard to say exactly what it was or where it came from. Their best guess is that it was linked to the Geminid meteor shower, which happens in December. And that actually makes sense. Lunar impacts are more likely to be spotted during big meteor showers, when the moon passes through streams of leftover space debris. So this could be one of those moments where the timing was just perfect. Now, the Geminid meteor shower is tied to one of the strangest space objects we know of, called Phaethon. It's labeled an asteroid, but it certainly doesn't behave like a normal one. You see, when Phaethon gets close to the Sun, it brightens up and even forms a tail, just like a comet. But its tail isn't made of dusty material the way comet tails usually are. According to NASA, its tail is made of sodium gas. That's why scientists are not totally sure what to call it. So, for now, Phaethon is officially listed as an asteroid. but a very weird one. Anyway, this strange object swings closer to the Sun every December, and when the heat gets intense, Phaethon starts shedding tiny bits of rock. When those little pieces dive into Earth's atmosphere, they burn up and make bright streaks across the night sky. At the peak of the Geminid shower, people can spot up to 120 meteors an hour under perfect conditions. The Geminids are usually bright and fast, and they often look a bit yellow. Of course, not all of those pieces hit Earth. Some miss us completely, and a few end up hitting the Moon instead. And that's probably what Marshall Lee saw that night. Now, even though the impact wasn't huge, flashes like this are still really useful for science. Astronomers use them to estimate how often the Moon gets hit by small space rocks. And once they know that, they can make better guesses about how many bigger asteroids are out there, the kind that could make it through Earth's atmosphere and cause real damage. And sightings like this matter for the future too, especially for space travel. Space agencies want to build bases on the Moon, and the goal is to make it a place where people can stay and work, not just visit. The Moon is our closest neighbor in space, so it's a great place to learn new things and try out new tools. It's also the perfect practice ground for bigger missions later on, like sending humans to Mars. NASA, for example, is working on something called Artemis Base Camp. The plan is a small base near the Moon's south pole, with places for astronauts to live and work, plus a rover that can travel farther from where they land. NASA also has plans for the Lunar Gateway, a small space station that would orbit the Moon and help crews and supplies move between Earth and the Moon's surface. There's also the International Lunar Research Station program. Its goal is to build a long-term research base on the Moon, starting with robotic missions that land first and prepare the area before people arrive. The program focuses on using local resources, such as ice in the Moon's soil, to produce water, oxygen, and other supplies needed for life. By staying on the Moon for longer periods, scientists hope to learn how humans can live and work far from Earth and use this experience to prepare for future missions to Mars and beyond. So, keeping an eye on these impacts and learning more about them could actually help us build a safer future beyond Earth. The more we understand how often these hits happen and how strong they are, the better we can plan and protect future lunar bases. In a way, that tiny flash on the Moon isn't just a cool moment on a screen. It's a small warning and a useful lesson for what comes next. You step on the surface of the Moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the Moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the Moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo Seismic Network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists have recorded quakes, tremors, vibrations, and shakes in other regions of our solar system too. Let's take Mercury, for example. A few years ago, scientists discovered that this planet was shrinking, and that's why it seems to be so tectonically active. Or Venus. This world is a tectonic puzzle for experts. At the moment, Venus has no tectonic plates, and it might have never had them. But its surface has folds and faults and looks as if it could have tectonic plates. On the other hand, these features might have appeared because of other processes, for example, volcanic activity. But even though we haven't observed any Venus quakes, scientists believe they could detect them since their vibration seems to ripple through the thick atmosphere of the planet. Now, Mars. We know for sure that this planet is seismically active. NASA's lander placed a seismometer on the surface of the red planet, and in 2019, it managed to measure its first Mars quake. After that, the lander continued to record quakes, but they were so weak that if they happened on our planet, they'd be completely covered by the background noise of Earth's oceans. But a space body doesn't have to be a full-fledged planet to have active tectonics. Let's take Pluto. This dwarf planet is geologically active at the moment. In 2014, NASA's New Horizons spacecraft was flying through the Pluto system when it recorded complex geological features on this dwarf planet. Scientists concluded that Pluto might have quakes, or should I call them Pluto quakes, when its liquid water ocean freezes and thaws beneath the dwarf planet's icy crust. Jupiter's moons, Europa and Io, as well as Saturn's moons, Titan and Enceladus, are also geologically active despite their small size. Their features range from volcanoes and water plumes to potential subsurface oceans. Now, I bet you don't know these cool facts about earthquakes that occur on our planet. There's one place on Earth where a whopping 90% of all earthquakes occur. It's called the Ring of Fire, and it stretches around the Pacific Ocean from New Zealand all the way to South America. Looks to me more like a horseshoe. Anyway, experts claim that these countless earthquakes are caused by the abundance of volcanoes in that region and the constant movement of the tectonic plates. Around 500,000 earthquakes happen on Earth every year, but many of them occur very, very deep in the Earth's crust, and only special equipment can detect them. We feel around 20% of earthquakes, and only 100 of them can cause damage. The largest recorded earthquake occurred in Chile in May 1960. It was a magnitude 9.5 on the Richter scale. It was truly devastating. During that earthquake, seismographs detected and recorded seismic waves that traveled all over the world. They shook the planet for many days. As for the most powerful earthquake that occurred in the U.S., it was 9.2 and happened in Alaska. By the way, Alaska, along with California, is the most earthquake-prone state in the U.S. and one of the most seismically active regions in the world. A magnitude 7 earthquake occurs there almost every year. A mega-earthquake can actually shorten the length of a day for the entire planet. NASA claims that really large earthquakes can shift our planet's axis and, thus, change the duration of a day. Now, of course, you won't notice it since this change is measured in microseconds, and 1 microsecond is 1/millionth of a second. Scientists think that the 9.1 Sumatra earthquake, which occurred in 2004, shortened the day by 6.8 microseconds. Now, not even the best specialists can predict an earthquake. That's mostly because the mechanisms that trigger earthquakes are extremely deep underground. But these days, people have learned how to figure out a more precise time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. gases spread all over the moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the moon. At one point, scientists got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the moon from Venus. Ooh. In that case, the moon shouldn't complain. I guess the view is way better here. So yeah, the moon and Earth are similar when it comes to rocks and some minerals. But the moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the moon was like many, many years ago. The moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air, and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder, about 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned, about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon. The large ball of fire thousands of miles away from us is the brightest object in our solar system, as well as the biggest. If Jupiter was the size of a basketball, then the Earth would look like a tiny little grape. But the Sun makes even Jupiter look like a joke. That big burning ball in the sky is made up of hydrogen and helium, and is 864,000 miles in diameter, making it more than 100 times wider than our little blue planet. It's 10,000 degrees Fahrenheit just on the surface, and 27 million degrees at the core. The moon, on the other hand, is a little easier to grasp at around 2,160 miles in diameter, which is only less than a third of Earth. It might seem pretty big floating in the sky, but that's because it's the closest object to us. But what if the tables, or in this case, celestial bodies, have turned, and the moon suddenly became brighter than the sun? Let's explore several scenarios. Scenario 1. If the moon becomes brighter than the sun, the nights will be brighter than days. It means your sleep cycle will be disrupted. All nocturnal animals will be utterly confused. When is it time to go out and eat now? In the extreme north and south poles, the nights and days are for months on end. So people living in the area already have an idea of what it's like to sleep at 11 p.m. with the sun shining brightly above them. For the rest of us, it won't be easy. Let's say you're out camping and prepare an awesome meal and gear up for the dark nights. As you trek into the forest, you find a spot that has an awesome view of the lake and the clear sky above. It's 7 p.m. and you start a fire for some s'mores and get the telescope ready. The only problem is that when the sun begins to set, the moon lights up the sky even brighter. It's surprisingly not as hot as you'd imagine, since it's not direct sunlight, but regardless, it's still pretty hot. Scenario 2. Temperatures will surely rise either way. That means snow will melt away faster than you can go, What's going on? The snow on the mountains will be the first to melt, followed by the polar caps. With so much heat, the sea levels will rise and take small remote islands scattered across the ocean underwater. Coastal towns will go down and everyone will live closer inward. This will likely cause a chain reaction in the world economy. There will be no more winters, which means no more winter activities like skiing, snowboarding, or snow fights. Animals and plants all around the world will be affected. The world will turn into a large desert. Water will get scarce over the years, but people will find a way to preserve it. Scenario 3. You're sitting behind your desk, bored. You're losing business. People aren't buying as many sunglasses as you thought. But when the moon suddenly becomes brighter than the sun, and everyone needs to wear those glasses 24/7 when heading outside, you can't keep up with the demand for sunglasses, so you hire more people and grow your business. You eventually become the best sunglasses business in the country. They don't recommend looking up at the sky at any point of the day or night. Cities are covered with large visors to reduce the brightness every day. Sunglasses will come in different sizes and shapes for different times of the day. Some will be like goggles strapped around your head, while others will be like large helmets. Scenario 4. The moon's atmosphere is so thin that it can't contain anything in it. Just like over deserts on Earth, there are no clouds to bring some rain, which is why it's always hot or cold. Yeah, the biggest desert in the world is the whole continent of Antarctica, which is a cold, barren desert, contrary to what people think of the Sahara Desert. So if you still want to land on the moon, you better think twice now. People who are working at the International Space Station will have to find a new office. The moon will be too bright to bear, considering how close they are. If the moon is just brighter than the sun without the heat part, then the space station will only require adjustments to keep the light out. The reason why we see the moon in various shapes is because of its position in relation to the sun. The moon doesn't rotate, unlike Earth. It's kinda glued to us and is always showing the same side. So, depending on the moon's position during the month, we'll have a super bright night during the full moon and relatively shiny nights during the rest of the month. Scenario 5. If the moon became brighter than the sun, it would produce more heat than the sun and probably become larger. Gravity on Earth would change significantly because of the moon's new size. The whole orbit structure would change and affect the celestial objects floating in space. Planets would soon begin to orbit around the moon. Earth might move further away from the sun. If that happened, then everything would have to readjust to the radical changes in gravity. Weak gravity means buildings wouldn't have a solid foundation to sit on and would eventually collapse. Bridges and large monuments would also fail to hold up. People wouldn't be able to walk properly and would do it in a funny way. Scenario 6. In many of these scenarios, I mentioned how the moon would be brighter than the object emitting light, but in this case, the sun would have to come from the moon reflecting from the sun, which means that the sun would have to be twice as bright as it is now. If the sun got 100 times bigger, it would shoot out more rays, which can be damaging and throw off a lot of radiation, harmful to every living thing on Earth. The gravitational pull of the sun might attract more planets to orbit around it and cause other objects in space to join the orbit. The planets would be partying in our galaxy club, and we might be thrown off our orbit course. Of course, this would pose a bigger risk to everything on Earth as things would get hotter and drier than before. Scenario 7. If we're talking about the moon getting brighter, we can also assume it would get closer to Earth than it is now. The brightness won't be the problem here, as gravity will cause major changes on Earth. But every day, 24/7 will be high tide. It will be so extreme that there will be constant floods in every coastal town. All islands will be submerged, which will increase the population of inland cities. Marine life will be having the time of its life when water overtakes the land. Boats will have to be re-engineered for new conditions as well as submarines. Air travel will be the priority, but large cruise ships will look futuristic and have an extra build to sustain the harsh waves. Nighttime will be pretty bright on regular days. It will raise the global temperature, which will melt down the snow, causing the sea levels to increase even more. Comets and other celestial objects will be drawn to a closer gravitational pull, so we will always have to look up whenever we go outside. But no worries, the moon is still up there as it is for a very long time. The Earth and the moon's relationship is complicated. Luckily, we only have one natural satellite. Other planets in our solar system have multiple moons revolving around them. Some are so huge that they're the size of Earth. Imagine several of those affecting our home, but that's a topic for a completely different story.
Sometimes when you look at the moon, you see a face smiling down at you from the moon's surface. Of course, this is an illusion, but many people see it, and that's because its surface is shaped by some sort of lunar seas and highlands. From our point of view, we see these as light and dark patches. These seas are dark parts, and large hardened lava plains formed because of volcanic eruptions that happened a long time ago. The light regions are actually the mountains and the highlands. And people all around the globe see these lunar patches as a smiling face or even some other shapes. Our brain tends to play with things of this nature, and that's a phenomenon called pareidolia. It's when you see familiar faces and shapes even though they're not actually there, similar to how you can see a face in a slice of toast or shapes while watching the clouds. And in the northern hemisphere, people see a face in those different lunar seas. The eyes are the sea of serenity and rain. The sea of clouds represents his mouth, while the seas of islands and vapors form his nose. But that's just one way to interpret this picture, and that mostly works in the northern hemisphere. If you live in the southern hemisphere, you see the moon the other way up. When they look at the moon, some see a person that looks like they're carrying a bundle of sticks. Or there's the shape of a woman. She wears her hair up and it has 2 jewels in it, and they see the left side of her face in profile. One of the craters is reminiscent of a shining diamond which, it seems, she's wearing around her neck. In some places, people may see the shape of a rabbit, whereas people from the Pacific Northwest in America even have a story about the toad they see when looking at the moon. The story says there was a wolf that fell in love with a toad, and the toad didn't quite trust the wolf since it wanted to escape and didn't know where. It simply made one huge leap and landed on the moon. Now, do other planets have beautiful rainbows like we do? The ingredients for that are raindrops and sunlight. At the moment, we don't know of a planet with liquid water on its surface, and none have enough water in their atmosphere to make it rain. But droplets of some other liquid could refract light coming from the sun and spread it out into various colors. Titan is one of Saturn's moons, and the atmosphere there is rich in droplets of liquid methane, which probably form rain. The atmosphere on Titan is very hazy. That means that direct sunlight is not that common, but there's still a slight chance we could catch methane rainbows someday. If they really exist, they'd be similar to rainbows on Earth, but they'd be a bit broader because methane refracts light differently than water. There's a similar thing on Venus called glory. Scientists caught pictures of this optical phenomenon of sunlight falling on sulfuric acid droplets, similar to a rainbow. Jupiter is insanely big, around 11 times wider than Earth. Not only that, our planet is twice as small as its Great Red Spot, the raging storm that's been present on the planet for more than a century. Now, we owe Jupiter a lot. Its radiation is 1,000 times stronger than the lethal level for us, and the gravitational force is so powerful that it actually protects our planet from collisions. In some other planetary systems, giant planets like Jupiter can move around and migrate from the place where they were originally formed. They spiral inward and get closer to their stars. When they move around, they can cause a lot of trouble. When they get closer to their stars, they can swallow and destroy some innocent small planets or other celestial bodies that stand in their way. But if these giants remain far away from their stars, they serve as guardians of the planetary system. They protect the planets in the inner orbits and allow them to circle around a central star. Jupiter got the nickname vacuum cleaner of the solar system because it can eat up any comet or asteroid that comes close enough. It can also change their orbits and kick them out so they can't come back for a very, very long time. That way, Jupiter protects the inner planets, although sometimes it accidentally sends asteroids or comets into them, causing collisions like maybe the one that made the dinosaurs extinct 65 million years ago. Now, Saturn's rings are the most famous ones in our solar system. They are far-reaching, colorful, and highly visible. You can even see them using a backyard telescope. But some other ice and gas giants also have them too, like Uranus. It has the second most interesting set of rings in our solar system. There are 13 rings, and they're all made of very dark particles that are different sizes. They're most likely young, way younger than Uranus itself. One theory says high-speed impacts shattered one or more moons, and this may have been the matter these rings are formed of. There were way more particles of debris, but only some survived, and today are forming stable zones around Uranus, known as rings. Now, our planet lost 60% of its atmosphere when there was an asteroid impact that, as one theory says, probably created the Moon. The collision between Earth and a Mars-sized rock happened over 4 billion years ago. The debris from all that collected in an orbit around our planet eventually formed the Moon. Now, Venus is home to at least 37 volcanoes that were active recently, which is the first evidence that showed its interior is still geologically active. Previous research discovered that the planet's interior was warm, plus there were ring-like structures. Plumes of extremely hot material deep inside Venus rise through the mantle layer, and that's how these structures form. It's like how plumes form the volcanic areas of the Hawaiian Islands. But scientists think they were just a result of some ancient activities. They believe Venus has cooled enough and drastically slowed down geological activities in its interior by hardening the crust so much that all of the warm materials from deep inside can't get out to the surface. Speaking of volcanic eruptions, Jupiter's moon Io also has them. Our moon is pretty peaceful, but Io has hundreds of volcanoes, and it took the title of the most active moon in our solar system when it comes to volcanoes. If you could go there, you'd see plumes of sulfur that reach up to 190 miles into its atmosphere. Volcanoes there emit 1 ton of particles and gases into space near Jupiter, its parent planet, every second. This could be because Jupiter's strong magnetic field and gravitational force. Io's interior tenses up and relaxes as it orbits Jupiter, and gets closer to it and farther away from it, which generates huge amounts of energy, enough for volcanic activity. There are billions of comets in our solar system. Most of them are in the Oort cloud and the Kuiper belt. A comet generally consists of rock and ice, at least until it gets closer to the Sun. Then its exterior turns into a cloud of dust and gas, and that's why comets have their specific tails. Pluto's unique surface is a series of domes, peaks, and troughs on the planet's landscape, which may have been formed because of its many large ice volcanoes. Neither erosion nor some other geological activity has done that much, but its ice volcanoes actually push icy material up to the surface. There are also a couple of craters in this area of the hemisphere called New Horizons. Asteroid impacts probably caused these. Plus, these craters aren't that geologically old. Also, the interior of Pluto probably retained heat, which enabled matter rich in water and ice to deposit onto the surface. And those specific structures I mentioned before could have formed because the water was rising up from the interior of the planet and ended up being rapidly frozen because temperatures on Pluto are extremely low, in addition to atmospheric pressures. Uranus is the second least dense planet in our solar system. The least dense one is Saturn. Now, even though Saturn is 14.5 times as massive as our planet, it's still less dense than water. This means that Saturn would float in a pool if it was more than 37,000 miles wide, so the planet would have enough space to even be in there. Whoa, that's a big pool. Now back to Uranus. Since its density level is so low, you probably experienced less than 90% of its gravity, assuming you could even set foot on its cloud tops. Now Mars has pretty crazy dust storms, the biggest ones in our solar system actually. They can blanket the whole planet and last for months. One theory says these huge storms start because dust particles absorb sunlight and warm the atmosphere of the red planet. Warm pockets of air form and they start flowing toward colder areas. This generates winds. These powerful winds lift more and more dust off the ground. This again heats the planet's atmosphere, creates more wind, and kicks up even more dust. Wow, better have a broom handy, maybe even two. Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes, traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the Moon, somewhere near the South Pole. This collision was so strong that it changed the image of the Moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the Moon. It caused damage to the Moon's mantle. It also created a so-called South Pole Aitken Base, or SPA Basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the Moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the Moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So, stay tuned for new exciting research and discoveries.